Hello, hello, I'm audible.
Good evening, sir.
Hello, good evening. So we will start within couple of a minute. So please wait. Uh, yeah, hello, good evening, all of you. So it's your first class. So today I will start with syllabus. What's your syllabus of your 12th class? Okay. So yeah, Ishima. Okay. So let's start our class. So first of all, what's the syllabus of your class? Let me discuss. My voice is clear to all of you. Hello,
Yes, sir.
my voice is okay. So let's start with our syllabus. Okay. So your syllabus is start with the first part is your is electricity and magnetism. Okay. So in this part, basically we will study the chapter number 1, which relates with electrostatics. Okay. And another chapter, which is current electricity. Current electricity. Electricity. Okay. This is your chapter number 2. And another chapter, chapter number 3, in which we will study magnetism. It is magnetism, and we say magnetic field. Okay, magnetic field and magnetism. This is the part of this chapter. And the next one, which is chapter number 4. In this chapter, we will study electromagnetic induction, electromagnetic induction, electromagnetic induction, and alternating current. Alternating current. And another part, including this electricity and magnetism, is electromagnetic wave. Electromagnetic wave. Okay, so this is a part of electricity and magnetism. Okay, so all these chapters are basically combined. These are all chapters related to each other. Okay, so we will start from electrostatics, then we will go to the current electricity, then after that we will study magnetic field and magnetism, and after that we will study electromagnetic induction and alternating current, and after that we will study electromagnetic wave. Okay, so this is a part of electricity and magnetism. Next, another part of your syllabus is optics. Okay, so in optics, basically we will study uh, the behavior of light, properties of light and behavior of light in different medium, and some very important property of light, reflection, refraction. Okay, and this comes under ray optics, dispersion, all this comes under ray optics. Okay, and another part of this chapter optics, we will study wave optics. Okay, wave optics. So the properties related to rectilinear path of the light is like refraction, reflection, and dispersion comes under the study of ray optics, and the properties such as interference, diffraction, and polarization comes under this wave optics. Okay, so this is the part of your optics chapter, and another part of your syllabus. Uh, these two chapter basically combined forms your sixth chapter, chapter number 6. Okay. Next part of your syllabus comes under modern physics. Okay, modern physics. Modern physics. Modern physics. Okay. So modern physics, in modern physics, we basically we will study about the dual nature of light. Dual nature of light and particle. Okay, so dual nature of light and particle. We will study in this chapter that light has both properties. Sometimes it behaves as particle and sometimes it behaves as a light wave. Okay, so it has dual nature, and particle also have dual nature. Sometimes it behaves as a wave and sometimes it behaves as a particle. Okay, so this is the first part of your modern physics. Another chapter is related to atom. So in this chapter, basically we will study how electron moves around the nucleus. Okay, what are the properties they hold, and some emission and some spectra. Okay, so this is the part of your chapter atom, and another part is related to nucleus. Nucleus and nucleus and radioactivity. Okay, so atom and nucleus. So these three chapters basically belongs to your modern physics. Okay, modern physics, and the final electronics. Final part is electronics. So in electronics, we will study semiconductor. Okay, semiconductor. So as you know, properties of conductors, insulators, you have already studied in your previous classes. In electronics, we will study semiconductor and semiconductor devices. Okay, semiconductor and semiconductor devices. So this is all about your syllabus. The major part of your syllabus belongs to this part, electricity and magnetism. Okay, it will take more than half part of your syllabus. Okay, and it will take, I think, 35 to 40 lectures I will take to complete this electricity and magnetism. And another part is optics. It will took, I think, 15 to 20 lectures. And another part, which is modern physics, it will took 10 to 12 lectures. and electronics will took 10 lectures. So this is a rough summary of lectures took for completing our syllabus. Okay. So this is all about syllabus. Any question? Anyone? Any student wants to ask any question regarding syllabus? Anyone? No one? Okay. So let's start our class from the very first one, which is electrostatics. Electrostatics. Chapter number 1, which is electrostatics. Okay. Electrostatics. So if you carefully read this word, which is electrostatics, okay, so it has two words basically, electro and statics. Electro and statics. So if we talk about electro means electron, or we can say charge particle. Okay. If charge particle, I will discuss what is charge, but first I'm saying if charge particle is at rest, if charge particle is at rest, okay, so the study of charge particle at rest is the study of electrostatics, okay. So as you know, what is the example of a charge particle? The very basic example of a charge particle is electron. So the study of electron at rest, there is no motion in electron, there is no motion. If electron is at rest, then the study of this part is belongs to electrostatics. What about if electron is at motion? If electron moves or charge particle moves, then then the study comes under electrodynamics. So electron at rest, then we call this is electrostatics. Okay. And when charge particle is in motion, if electron okay, if electron is in motion, then the study comes under electrodynamics. Now we are talking about dynamics of electron, and here the electron, any charge particle, is at static, and electron is motion. The study comes under electrodynamics. Okay, we will go to this part, means electrodynamics, because when a charge particle moves, it associates not only electric field, is also associates some magnetic properties, magnetic field. The study of the magnetic field and electromagnetic induction comes under this part, electrodynamics. But first we will consider very basic example, electron at rest. And that study comes under electrostatics. Okay, is it clear to all of you? Okay, means what is the what we are going to study? We are going to study about charges, charges and charges at rest. Okay, at this point we will not talk about its motion. We will just talk about the charge put at rest. Okay, is it clear?
Yes, sir.
So now let's go and talk about what is electric charge. What is electric charge? Okay, so very fundamental thing, it's electric charge. Electric charge. Okay, electric charge. So there is a very good definition of electric charge, that electric charge is an intrinsic properties. Electric charge is an intrinsic property, is an intrinsic property of fundamental particles. Okay, so how many undefined word here? So undefined word is like intrinsic property. What is intrinsic property? So intrinsic property we define as intrinsic property what we can't remove. It is the basic property. Okay, it's like mass is a intrinsic properties of matter. Mass is a intrinsic property of matter. You can't define mass with some other property. Mass is itself defined in terms of other variables. Okay, so mass is an intrinsic property of matter. Same as electric charge is also an intrinsic property of matter. Okay, so mass is an intrinsic property of matter, and charge is an intrinsic property of matter. And there is one more thing, which is spin. We will not talk about spin here, but spin is also intrinsic property of matter. Electron had spin up and spin down, which we will study in our modern physics part. Okay, not here. So as we discussed that electric charge is an intrinsic property of fundamental particles. And what are fundamental particles? Fundamental particles are those particles which are fundamental. Okay, such as electrons, protons, and neutrons. These particles are fundamental particles. Okay, these are different from elementary particles. Elementary particles basically are those particles which are unbreakable. You can't break them. So that are elementary particles. You can't break an electron, but you can break a proton. Okay, proton has structure. So elementary particle, those particles which are structureless. Okay, so here we are talking about electric charge is an intrinsic properties of fundamental particle. Fundamental particles such as electron, and proton. Fundamental particles such as electron and proton. Okay, so electric charges. So mass, as I told you, mass is an intrinsic property, and charge is also an intrinsic property. So masses are responsible for gravitational force. All of you know that masses are responsible for gravitational force, and same as charges are responsible for electric forces. Okay, charges are responsible for electric forces. So this is an important point, that masses are responsible for gravitational forces. Okay, and another thing, which is charges are responsible for electric forces. Or you can say electrostatic forces. Okay, so but there is a difference between electric and gravitational forces. What kind of difference it is? It is because mass have only attractive property. Okay, if you put two masses, one mass and another mass, and you come close to them, then they will only attract. But charges have different property in comparison with mass. If you put two charges, then they attract and they also repel each other. Okay, they also repel each other and they also attract. So how many kinds of charges exist in nature? How many kinds of charges exist in nature? Anyone? How many kinds of charges exist in our nature? Anyone? Okay. So there are two kinds of charges we talk, basically two kinds of charges, two kinds of charges, okay, exist in nature. The one is positive and the another one is negative. There are two kind of charges we talk about, and if a particle is neutral, then we say it has equal amount of positive and negative charges. Then we say it has equal amount of positive and negative charges. Then the body is neutral. Okay, and the example of neutral particle is the example of positive charge. The example of positive charge particle. Which one is positive positive charge particle is proton. Proton has positive charge. Okay, and electron has negative charge. Electron has negative charge. Okay, and anyone can tell me what is a neutral charge particle? A particle uh, which is neutral. Anyone? What is a fundamental particle
Neutron.
which is neutron? Exactly. So the neutral particle we talk about, it's neutron example. Okay, neutron is neutral in nature. Okay, neutron is neutral in nature. Okay, so if a body has equal amount of positive and equal amount of negative charge, then that body behave as neutral particle, neutral body. Okay, it will attract or neither it will repel. It's a neutral. And all of the classical, in our classical world, all of the bodies mostly are in neutral state. Okay, they doesn't attract or repel each other, they basically in neutral state. But if you put electrons from outside of that body, then in that case it will show some repulsion or attractive behavior. Okay, otherwise most of the bodies are neutral, in neutral state. Okay, so this is all about electric charge. Some important point about this electric charge is the electric charge is a scalar quantity, such as mass is a scalar quantity. Mass is a scalar quantity, na? It has only magnitude, it doesn't have direction. So mass such as mass charge is a scalar quantity. Everybody know what is scalar quantity? Okay, so scalar quantity means it has only magnitude, it doesn't have any direction. Charge is a scalar quantity, it's an important point. Charge is scalar quantity. Okay, and another part is its SI unit. The SI unit of charge, SI unit is coulomb. Okay, we represent as capital C. The SI unit is coulomb. So charge is not a fundamental your variable. It's not a fundamental thing. The motion of charge means current is a fundamental variable. Means when we define our unit. So in that case, there are 7 fundamental variables, and in that case, charge is not a fundamental. Okay, current is a fundamental quantity. So if we compare one more important property about charge charge is scalar quantity. It has SI unit is coulomb. We represent it with capital C. One more important point, that the smallest number to define a charge. Okay, the minimum amount of charge, we consider it as charge on electron. This is the minimum amount of charge. Okay, we define charge in the integral multiple of the charge of electron, but this is the minimum amount of charge. Okay, so charge on electron, this is the minimum amount of your charge on electron. कितना है? How much it is? It is 1.6 into 10 raised the power 90. 1.6 into 10 raised the power minus 19 coulomb. So this is the minimum amount of charge which holds electron and also on proton. Electron and proton has equal amount of charge, which is 1.6 into 10 raised the power minus 90 coulomb. Okay, so these 3 points are actually very important. Charge is scalar quantity. It has SI unit, which is coulomb, and charge on electron is 1.6 into 10 raised the power minus 19 coulomb. Okay, so up to now, anyone has any question, then they can ask. Okay, so next we are going to study, if we compare our mass, then how charge is different from mass. Okay, there's some important point which I am going to discuss. Mass, and here is charge. As you know, mass has only attractive behavior, means it is only positive. Okay, and attractive in nature, and attractive in nature, while charge is positive and negative, and it is attractive and repulsive. Is attractive and repulsive. Attractive and repulsive. Attractive and repulsive. Okay. And another point related to mass and charge, that mass corresponds gravitational force. Mass corresponds gravitational force. Okay, and charge correspond what kind of force? It corresponds electrostatic force. Electrostatic force. Electrostatic force. Okay, and the another important point, which is when you take a mass, and if that mass, if you are considering a mass, and if that mass moving very fast, okay, moving very fast means its velocity is very high, it's close to speed of light, then in that case mass get varies. M naught under root 1 minus v square by c square, means mass varies with speed. Okay, mass varies with speed, while charge is an invariant with speed. Okay, charge remains invariant. Charge remains invariant with speed. Okay, so these are basic difference between mass and charge. The first one, mass is only positive, it has attractive in nature, and while charge is negative and positive, and it attractive and repulsive both. And due to mass, the force experienced is gravitational force, and due to charge, the experienced force is electrostatic force, and mass varies with speed, and charge remains invariant with speed. Okay, so this is all about difference between mass and charge. Both are intrinsic properties of matter, but they are different in behavior. Okay, so now one more thing I want to discuss is that whenever we talk about a body is charged or it's uncharged, how can you define a body is charged? How can one define a body is electrically charged? Okay, so this is the question. How can one define a body is electrically charged? Means it is positive charge, is it a negative charge? How can you define a body is charged? Anyone wants to give his point about how a body electrically charged? Means we are charged or we are not charged? Anyone wants to give his point? Okay, nobody wants to give his opinion or point about charge, about this
When
question.
electrons are more than protons, it is negatively charged, and when
Okay,
protons are more than electrons, it's positively charged.
okay. So that's the correct answer. So suppose if I choose a body, okay, as you know, body, any part of matter you choose, it has nucleus and surrounding electrons. Okay, so nucleus has a positive charge. Nucleus is made of protons and neutrons, and electron moves around this nucleus. Okay, so suppose nucleus has some positive charge, means if a nucleus has 4 protons, 4 positive charge, and is surrounded with 3 electrons. 3 electrons. Okay, it's surrounded with 3 electrons. 3 electrons. So in this case, it has 4 plus charge, and it has -3 charge. So in this case, this body is positively charged. Positively charged. Okay, and another part, if we choose, suppose this is a nucleus, it has again 4 plus charge and surrounded with electrons. Now electrons I choose 1, 2, 3, 4, 5. Okay, so in this case it has again 4 positive charge minus 5 negative charge. So in this case it is negatively charged. It is negatively charged because it has more electrons in comparison to protons. And if a body has equal amount of positive charge, if a body has equal amount of positive charge and equal amount of negative charge, then in that case, as I already told you, it is neutral body. It has 4 positive charge and -4 negative charge. In this case, it is neutral, or it has neutral. Okay, so net charge is 0. We define net charge 0. Net charge is 0. Okay, so in this way we can define a body is positively or negatively charged. Net charge is 0. So these are basically some basic points related to this electrostatic chapter. Okay, so now next part, how can we charge a body? One more important point is, whenever we talk about charging of a body, means a body is positively charged or negatively charged, we always consider electrons, not protons, because proton are exist inside the nucleus. Okay, so whenever two bodies rub each other or due to conduction or induction, always electrons get transferred. Always electron gets transferred, means from one body to another body the exchange of electrons may possible, but no exchange of proton possible, because proton exists inside the nucleus, and there the forces are different from these electrostatic forces. Okay, there is a there exists actually strong forces which are much stronger than these electrostatic forces. Okay, yeah, as we know, electrostatic forces are stronger than gravitational forces, but inside the nucleus there is a different kind of force exists which we call strong forces. Okay, so that's why we never talk about the transfer of proton, we always talk about the transfer of electrons. Okay, so whenever we rub two bodies, means if I rub this pen with a cloth, okay, then there is an exchange of electron from this pen to that cloth. Okay, so in that case one body gets positively charged and another body gets negatively charged, okay, due to transfer of electrons. Next part we are going to discuss is charging a body. Charging a body, how can we charge a body? Okay, how can we transfer these electrons? So next point is related to charging of a body. Charging of a body. Okay, so there are three methods which through them we can charge a body. There are three methods. The first one is through conduction. The first one is through conduction, and the second one is your induction, charging through conduction, and then next one is charging by induction, and the another one charging by friction, and we also call this frictional electricity. The third one is charging by friction. Okay, so let's talk about how we can charge a body through conduction. How can we charge a body through conduction? Okay, so the first one is charging by conduction. Okay, charging by conduction. Okay, charging by conduction. So when we put two bodies in contact, when we put two bodies, one is charged body and another is uncharged body. Okay, or we can say discharged body. So when we put a discharged body in contact with charged body, then this type of charging, contact with charged body, then discharged body gets charged. Okay, and this type of charging is called charging by conduction. Charging by conduction. Okay, now let's try to understand. So suppose I take a body which is charged. Okay, suppose it has negatively charged and it has 4 electrons. Okay, it's a negatively charged, and I put another body which is neutral, which is discharged. Okay, so what happened? The charge get equally distributed in both the bodies, and in that case uh, uh, the first body gets 2 negative charge and another body gets 2 negative charge. So in this way uh, these two bodies share their charges. So how they share their charges? Suppose it has minus 4e charge, it has 0 charge. So in this case, the first one gets charge minus 4e plus 0 by 2, and again this one is minus 4e plus 0 by 2. So in that case, both have minus 2e and minus 2e. Okay. So in this case, they share their charges, and if you detach these two bodies, then they have both bodies have minus 2e and minus 2e charges. So in this case, one discharged body gets charged through charging by conduction. Is it clear? Is it clear, all of you, or anyone has doubt? Let's take one more example. If I take a body which has plus 4e charge, okay, means it's positively charged, and another body which is suppose negative 80. Okay, so negative 80. So when you put in contact with this body, then what happen? Suppose now it's time, these are not in contact. One is 4e and another one has minus 80. Okay. Now when you put it in contact, then what happen? One body get charged, how much? It's plus 4e minus 80 divided by 2, and again it also plus 4e minus 80 divided by 2. So it's again minus 2e and minus 2e. Okay, so in that case both body has equally charged. Okay, so if you remove these two bodies, then in that case both body gets equally charged. Okay, so in this way we can charge by conduction. Okay, this is examples of charging of conduction. Is it clear now, all of you? Okay, okay, so now, okay, how many you have? Okay, if anyone have any question, then please ask. Okay, so now next is charging by induction. Suppose someone put some restriction on you. Okay, you can't basically put in contact. So what happened? Without putting two bodies in contact, how can you charge? Okay, how can you totally charge a body? Okay, so that method is we call charging by induction. Charging by induction. Let's talk about charging by induction. Okay, charging by induction. Okay, let's try to understand how can you charge through induction. So suppose I have a body. Okay, I have a body. Okay, in this case, if I put a rod which is positively charged, okay, one more body. Okay, these two surfaces are have identical basically. Okay, these two surfaces are identical. So if I put a rod very close to this sphere, first sphere, then what happened? Due to these heavily positively charged, when these positive charge rod comes very close to this sphere, then what happened? This portion of sphere gets negatively charged. This portion of sphere gets negatively charged. And when this portion of sphere gets negatively charged, then this portion has lack of charges. This portion has lack of charges, and due to this portion gets positively charged. Okay, this portion gets positively charged. And again, in our next diagram, I am showing that you put your rod very close to this negative one sphere, and now you detach these two spheres. So one sphere gets negatively charged, okay, and another sphere gets positively charged. So this complete body, which was neutral before, when you put a charged rod very close to this body, this two sphere body, then what happened? You can basically you charged one sphere with negative and another sphere with positive charges. Okay, so in this way you can charge a body by induction. Is it clear? So this is another method, charging of a body through induction.
Sir, can you explain again?
Yeah, sure. So I'm again explaining. So suppose, yeah, suppose you have two spheres. Suppose you have two spheres. Both are in neutral. Both are neutral. Means it has equal amount of positive and equal amount of negative charge. Okay. And what you do, you put a positively charged rod here, close to first sphere, positively charged. So due to this positive charge, when this positive charge comes close to this part, then what happened? This part gets negative. This part get negative. This part get negative. Okay. And due to this negative charge part, what happened? The last region, this one gets negative. This part has lack of negative charges. So this part gets positively charged. Okay, this part gets positively charged. It's like polarization part of, like, if you bring uh, some negative charge and you put another body very close to this charge, okay, neutral body, then what happened? Due to this negative charge, this region gets positively charged, and here there is the electron will collected at this part, then this part gets negatively charged. Okay, so in this way you can construct a region of positive or negative charge. Okay, you just have to bring some opposite charge close to the surface, and that surface gets positively charged. Like when you bring a positive charge rod, then this region gets negatively charged, and if you put a negative charge rod, okay, so here I put positive charge, so that's why this region gets negative. And if I put a negative charge rod very close to this region, then in that case this region gets positively charged. But here I use positively charged rod, so this region gets negatively charged, and due to this negative charge, this part has lack of electrons, and this part, if this part has lack of electrons, so this region gets positively charged. Okay, now you have two spheres, one is negatively charged and one is positively charged, and if you detach, okay, if you remove contact, then what happened? One sphere gets totally negatively charged, okay, and another sphere gets totally positively charged. So in this way, you basically you have a neutral body, you have a complete neutral body, and without putting any contact, you divided these two bodies in a positive and negative charge bodies. Okay, before the two sphere which are in contact, basically they are neutral. Okay, they are in neutral state, and you just put a rod very close to this sphere, not in contact, not in contact. So this is we call induction. This is we called induction. Okay, now is it clear?
Yes, sir.
Okay, so now next part we are going to discuss is charging by friction. Charging by friction. Charging by friction. Okay, so this is very easy to understand. This charging by friction means when you rub two bodies, then there is a transfer or exchange of electron. Okay, so in that case a body gets charged. Suppose when you rub a glass rod with a silk cloth, then in that case your glass rod gets positively charged and silk cloth get negatively charged. Okay, so there is a transfer of electrons. So in that case one body gets positively charged and another body gets negatively charged. Okay, so suppose I rub my hands. Suppose if I rub my hands, so there is heat appears. There's a heat appears, and due to this this heat will try to extract electrons from its surface, and in that due to this heat there is a transfer of electron from one surface to another surface. And when you rub silk cloths to the glass rod, then it also depends what kind of material you are using. If a material if electrons of that material is not tightly bound, then that material will easily leave the electron. Okay, and if a material has a property which has electrons are tightly bound, okay, so in that it's very hard to extract electron from its surface, then in that case it will not easily lose electron. Okay, so how can you distinguish that one material is easily leave electrons and another is not? It's defined, it's actually based on its own property. If electrons are tightly bound, then it will not easily remove electron. If electrons are loosely bound, then it will easily then you can easily remove electron. Okay, so actually Benjamin Franklin, who was pioneer in electrostatic experiments, he did actually these kind of experiment. You know, he rub a glass rod on over his cat surface, you know, cat body, and two balloons rub his he rubbed two balloons, then one get electrically charged. And also when I try to rub this pen over my hairs, then it will also get electrically charged, and it can attract some piece of papers. It can attract some piece of paper. All of you also already did these kind of experiments, you know. Okay, so these are called frictional electricity. Frictional electricity means by rubbing a body, when it gets charged, it attracts some another body. Okay, so this is we called charging by friction. Charging by friction. Charging by friction. Okay, charging by friction. Positive rubbing. Okay, so these are three ways you can charge a body. So this is all about the basic thing, very basic thing about charges. Very basic thing about charges. Okay, so now we can move to the some properties of charges. Okay, this is the part of syllabus where question can be asked. Basic properties of charge. This is actually important. Up to now we just discuss what is charge, you know, some very all of things related to charge, but they are not technical. Okay, they are not very technical, you know. Some very small things which we discuss, such as what is the unit of charge is important. You know, what is the unit of charge? What is unit of charge? We learned coulomb. Okay, always remember the unit of charge is coulomb. and charge is a scalar quantity. Charge is a scalar quantity. The unit of charge is coulomb, and one electron has charge 1.6 into 10 raised to the power minus 19 coulomb. Okay, these three things which are very important, which you must have to know. Okay, so next I'm going to discuss what are some basic properties of charge. What are some basic properties of charge? Basic properties of charge. Okay, so the first property of charge is additive in nature, or we can say additivity. Additivity. Okay, additivity. Okay, so additivity, the means of additivity is like if a body has mass, if you consider a system of bodies, and if a body has mass m1, another body has a mass m2, another body has mass m3, then you consider the complete mass as m1 plus m2 plus m3. Okay, because mass is a scalar quantity. Same as charges are also a scalar quantity, and when you take a system of charge, suppose a body has charge q1, q2, q3, q4 up to qn. Suppose you consider a body a system of charges. Okay, then the total charge of a system, then the total charge, and the total charge of a system is the algebraic sum of all the individual charges. Okay, the total charge of a system is the algebraic sum of all the individual charges. Means the net charge of this whole system can be considered as q is equals to q1 plus q2 plus q3 plus q4 up to qn. Okay, you just sum all the charges. Okay, so this we call additivity or additive in nature. Charges are additive in nature. So net charge, I can write here net. Q net is equals to q1 plus q2 plus q3 plus q4 plus up to qn. For example, suppose I consider a system which has minus 5 microcoulomb charge, and another is like 3 microcoulomb, and another is like 4 microcoulomb, and one more is like minus 1 microcoulomb. Okay, so this is a distribution of charge. So what will be the net charge over this body? What will be the net charge is like minus microcoulomb plus 3 microcoulomb plus 4 microcoulomb and minus 1 microcoulomb. Okay, so you just add all the charges, individual charges. So in this case, the net charge of the body is 1 microcoulomb positive. Okay, so this is one of the basic property of charge is additive in nature. Is it clear? It's very easy. Okay, is it clear, all of you? Yes or no?
Yes, sir.
Oh, okay, so now let's move to the next property. Next property is quantization of charge. The next property is quantization of charge. Next property is quantization of charge. Okay. So quantization is charge. What is the mean of quantization of charge? Quantization of charge. Okay. So charge exists in the multiple integral of the fundamental charge. Means there is a fundamental charge. Fundamental charge, as I told you, the fundamental there is a smallest number. Okay. In terms of charge exists. This, what is the smallest number? The charge on electron, which is 1.6 into 10 raised to the power minus 19 C. So we consider it as 1e, 1 electron. So we consider as 1 E is equals to 1.6 into 10 raised to the power minus 19 coulomb. So we always talk about the integral multiple of this 1e. You know, we always talk about a body has 1e charge, 2e charge, 5e charge, 10e charge. You know, we always consider charge in this term. Suppose a building has first floor, second floor, third floor, fifth floor, but you never talk about is there any floor between 1 and 2? No, there is no. We never consider any floor between 1 and 2. Okay, so in that case we always consider charges 1e, 2e, 3e, 4e, 5e. Okay, so in that case an e. So we call this property as quantization of charge. We always we consider this property as quantization of charge. So in one line we can write as charge exists in the integral multiple of fundamental charge, which is E, small e. Okay, and here we consider when E, as I already told you, minus 90 coulomb. Okay, so Q is equals to, we define formula, Q is equals to plus minus NE. Okay, plus minus NE means it's 1E, it may be 2E, it may be plus minus 3E, it may be plus minus 4E, but always integral multiple of E. Okay, so some very basic charges. Charge on electron, charge, you always remember how much charge on electron is minus E. Okay, minus E means minus 1.6 into 10 raised to the power minus 19 coulomb. And how much charge on a proton? This is charge of electron, or charge on proton. Proton is a particle, fundamental particle. How much charge it has? It has positive E plus E. Okay, 1.6 into 10 raised to the power minus 19. One more important particle. Okay, the charge of that particle, all of you must remember the charge on alpha particle. Charge on alpha particle, and it has a charge plus 2e. It has 2 times the charge of proton. Proton has a plus e charge and alpha particle has plus 2e charge. Okay, 2 into 1.6 into 10 raised to the power minus 19. Okay, so this is all about quantization of charge. Is it clear? Quantization of charge, is it clear? Okay, all of you, is it clear now? Mariam, Maziha.
Yes, sir.
Okay, and Muhammad Saif.
Yes, sir. Clear.
Okay, so now let's go to the another property, which is conservation of charge. Another property which is conservation of charge. Conservation of charge. Okay, so this property is same as conservation of mass. Okay, conservation of charge is like we can't create any charge. Charge itself exists in nature. We can't create or destroy any charge. Okay, so the total charge of this universe is conserved as mass. Total mass is conserved na. We can't create any kind of mass. We can transform mass one form into another form, but we can't create any mass. So same as we can't create any charge. Okay, and we can't destroy any charge. They can only transform. They can only transfer. They can only transfer from one body to another body. Okay, so this is all about conservation of charge. Okay, it's I think very easy. There is nothing very technical in this conservation of charge. Okay, so we can write charge neither be created, neither be created or neither be destroyed, neither be destroyed. Destroyed. Okay, they can only transfer. They can only transfer. Okay, and another one more point, the total charge of an isolated system remains constant. Okay, the total charge of isolated remains constant means we can consider the total charge of this universe remains constant. Okay, so this point is like the total charge of the entire universe remains constant. The total charge of the entire universe remains constant. Okay, so this is all about conservation of charge. Okay, conservation of charge. Now we discuss a lot of things about charges. Now let's do some problems. Okay, some very easy problems related to the formula which I discussed. You know, Q is equals to NE or some only one formula. The problem will be based on only one formula, which is Q is equals to NE. Q is equals to NE. So the first question is how many electronic charges from how many electronic charges from 1 coulomb of charge. Coulomb of charge. Okay, so it's very easy. Means how many electronic charges from 1 coulomb of charge. So here, what is the question? Question is you have to find what is the value of n. Okay, what is the value of n? So you know the formula, Q is equals to NE, and how many electronic charges in 1 coulomb. So here what is the value of Q? Q is given, which is 1 coulomb. Okay, and you have to find n number of electronic charges. So that is 1 coulomb divided by E. And what is value of E? The value of E is 1.6 into 10 raised to the power minus 19. So here 1 coulomb divided by 1.6 into 10 raised to the power minus 19 coulomb. So you can cut this coulomb to coulomb. And what is the final answer is 1 upon 1.6 into 10 raised to the power plus 19. And what is the value of 1 divided by 1.6? Tell me. What is the value of 1 upon 1.6? What is the answer? Try to calculate it. What is the exact answer of this thing? Okay, I am going to calculate it. It's a 10 upon 16. If I take 1 0 from here, so it's 100 upon 16 into 10 raised to the power 18. And if I divide 100 with 16, then it's 6.25 into 10 raised to the power 18. This is your n. Okay, next question. Is it clear now, or anyone have any doubt? Is it clear to all of you? It's a very easy question. Okay. Hello. Okay.
Yes, sir.
Okay. So next question. Try to solve this question. Next question. Next question is related to calculate the charge on alpha particle. Calculate the charge. Calculate the charge on alpha particle. Now let's try to solve this question. Calculate the charge on alpha particle. As I already told you, first thing, how much charge on alpha particle? Alpha particle has charge. Alpha particle has charge twice of proton charge, yani twice of E. Okay, and what is the value of E? It's 1.6 into 10 raised to the power minus 19. So the answer is 3.2 into 10 raised to the power minus 19. So this is the charge over alpha particle, 3.2 into 10 raised to the power minus 19 coulomb. Okay. Okay. Now next question. Next question. Calculate the charge. Calculate the charge carried by 12.5 into 10 raised to the power 8 electrons. Okay. Now try to solve it. Muhammad Saifullah and Mariam Maziha. Try to solve it. Calculate the charge carried by 12.5 into 10 raised to the power 8 electron. What is given here? What is given here? Anyone? Here, very good. N is given. So N is equals to 12.5 into 10 raised to the power 8. And you know what is E? E is 1.6 into 10 raised to the power minus 19. And what you have to calculate, you have to find what is the value of Q. It's very easy. Q is equals to NE. You can get the answer. Now tell me the answer. What is the answer? Anyone? Okay, you message 2 into 10 raised the power. Okay, so 2 into 10 raised the power minus 10. So here Q is equals to any means 12.5. Q is equals to N into E. The value of N is 12.5 into 10 raised the power 8 into E. The value of E is 1.6 into 10 raised the power minus 19. And if you multiply, then you will get 20 into 10 raised the power minus 11 coulomb, and that is 2 into 10 raised the power minus 10 coulomb. Okay, so this is your answer. Okay, one more question I will give you, so that all of you have enough practice of the formula. Today we just talk about charges, charges. Up to now we have learned a lot of things about charges. Now it's time to do some numericals. Next question is, a comb drawn through person's hair, drawn through person's hair causes 10 raised the power 22 electron to leave the person's hair, to leave the person's hair and stick to the comb, and stick to the comb. Okay, calculate the charge carried by the comb. Calculate the charge carried by the comb. Okay, so this is the problem. A comb drawn through person's hair causes 10 raised the power 22 electron to leave the person's hair and stick to the comb. Calculate the charge carried by the comb. Okay, so in this question, what is given here? So given is the number of electron. You know how much number of electron which leaves the person's hair and stick to the comb. Okay, so here the number of electron which leave through the person's of hair is 10 raised the power 22 electron. Okay, and one electron has charge. One electron has charge. It's 1.6 into 10 raised the power minus 19 coulomb. Okay, and you have to calculate the charge carried by the comb. So again, Q is equals to Ne, and N is 22 electrons into 1 electron charge, which is 1.6 into 10 raised the power minus 19. So the answer is 1.6 into 10 raised the power 3 coulomb. Okay, and the question is calculate the charge carried by the comb. So you are talking about, here we are talking about electrons, so the charge is minus 1.6 into 10 raised the power 3 coulomb. Okay, 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 is it okay to all of you?
Yes, sir.
Okay, so this is all about charge. Now we can go to the next part of this chapter, which is about forces. Okay, this is about some forces. So here I think I covered all the properties, all the important points related to your charge. Okay, related to your charge. What is charge? We discussed what is charge, and what kind of charge exists in our nature. Okay, what kind of charges exist in our nature, and charge is scalar. Okay, I discussed charge is, okay, let's take a small revision. Okay, so I discussed kinds of charges. I discussed it's a positive, negative charge. Okay, charge, these three properties are actually important. That charge is scalar quantity. Okay, and SI unit is coulomb, and charge on electron is 1.6 into 10 raised to the power minus 19. These 3 points are actually important. And some comparison relate between mass and charge, means mass has only positive, it is only attractive in nature. Charge both positive and negative, it has properties attraction and repulsion. And mass causes gravitational force, while charge causes electrostatic forces. Okay, and mass varies with speed, means if you are considering very high speed, then in that case mass varies. And charge never varies, charge is invariant with the speed. This is a very important point. This point is very important. Okay, charge is invariant with the speed. Okay, and after that I discuss how can you charge a body. There are 3 ways you can charge a body: charging of a body, conduction, induction, and charging by friction. Okay, in this way, in this part I discuss how can you charge a body by conduction, how can you charge a body by conduction, how can you charge a body by induction. Okay, and finally charging by friction. And after that I discuss some technical part, means some basic properties of charges. The first property of charge is additivity. Means charges are considered a system of charge considered as the sum of individual charges, algebraic sum of all the individual charges. And another property which I discussed um, is quantization of charge, means charge exists in the integral multiple of fundamental charge. From here we get a formula which is Q is equals to Ne plus minus Ne, where N is the number of charge and E is a charge on a electron or proton. And after that I discuss what is conservation of charge. Conservation charge, in which we discussed we can't create or destroy any charge. The total charge of entire universe remains constant. And after that we did some numerical, some very easy numerical based on the formula of quantization of charge. Okay, so this is all about charge. Now next I'm going to discuss the Coulomb's law of electric force. Next I'm going to discuss what is Coulomb's law of electric force. Coulomb's law of electric force. Okay, Coulomb's law of electric force. Okay, so this Coulomb's law of electric force is same as the law of gravitational force, Newton's law of universal gravitation force. So for example, if I consider two massive body, if I consider a body of mass m1, if I consider a body of mass m1, and if I consider a body of mass m2, okay, and they are apart from each other by a distance small r. Okay, and this small r is a distance between the center to center, means the center of mass m1 to the center of mass m2. Okay, so I again dash line from center of mass m1 to center of mass m2. Okay, so in this case the body will experience, both the body will experience a gravitation force. m1 will experience a force due to m2, m2 will experience a force due to m1. In this case the this body will experience a force F which is directly proportional to mass m1 into mass m2 divided by the separation distance, the square of separation distance between these two bodies. Means F is directly proportional to m1 m2 divided by r square. Okay, and if we remove this proportionality, then we have a constant. What kind of constant it is? It is capital G m1 m2 divided by r square. Okay, in this case capital G is the universal gravitational constant. In this case capital G is, we call capital G is universal gravitational constant. Okay, universal gravitational constant, capital G. Next, if I talk about charges, okay, if I talk about charges, so this case actually is for gravitational force, and this gravitational force have only attractive. Okay, this force is only attractive. This force is not repulsive. If I compare this system to the system of charges, if I consider a charge q1, okay, a q1 charge and another charge is q2, another charge is q2, and the distance from its center to its center is small r. If the distance from its center to its center is small r, okay, then these two charges also experience some kind of force. These two charges will experience some kind of force. This force is directly proportional to charge, the product of these two charges q1 and q2. Okay, the product of this charge q1 and q2, and also inversely proportional to the square of distance between these two charges. Means you can say that F for this force is directly proportional to the product of these two charges, and this force is inversely proportional to the square of distance between these two charges. Okay, so if you combine these 2 points, the first one, suppose I consider it first and second, if you combine these two equations, then you can directly write F is directly proportional to q1 q2 divided by r square. Is it clear? If anyone has any kind of doubt, means F, the force which exists between these two charges, basically these two charges if gets interact, then a force will exist. This force we call electrostatic force or Coulomb's force, and this force is directly proportional to the product of these two charges, magnitude of these two charges, and this force is inversely proportional to the square of distance between these two charges. So if we combine these two equation or these two facts, then we can write F is directly proportional to Q1 Q2 by R square. Okay, and if I remove this proportionality constant, so I get F is equals to K Q1 Q2 by R square. Okay, and this K we call here, this K we call, K is electrostatic force constant, okay, and this F we call, F is equals to K Q1 Q2 by R square. This F we called Coulomb force. Okay, this is also considered as electrostatic force, we also called it Coulomb force. Okay, and what is the value of this K? K is equals to, in vacuum we define K is equals to 1 upon 4 pi epsilon naught. It's a constant, and it has the value 9 into 10 raised the power 9. And what is the unit of this K? Newton meter square per coulomb square. Okay, so this is the value of K. And here what is epsilon naught? I will discuss what is some other points related to epsilon naught. I will discuss it in brief, but in other lecture, not in this lecture. But I'm introducing this epsilon naught. This is we call permittivity of free space. This is we call permittivity of free space. Okay, it tells about the medium. If you put this charge in some another medium, if you put this charge into liquid, okay, in water, in air, here we are talking about vacuum. In vacuum we use epsilon naught, okay, permittivity of free space. But if I put this system of charges in water, in air, then in different medium the value of K is different. But in vacuum it has the value 9 into 10 raised to the power 9 Newton meter square per coulomb square. Okay, so this force we called Coulomb force or electrostatic force. This force we call Coulomb force or electrostatic force. This force we call Coulomb force or electrostatic force. So the complete formula is F is equals to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. This is your complete formula for your electrostatic forces. Okay, this is your equation. Take a note of this formula. Are you taking notes, all of you? Hello? Hello? Mohammad Saifullah, are you taking notes?
Yes, sir.
Okay, you are not asking any question. If you have any question, then ask.
No, it's clear,
Okay.
sir.
It's clear now. Okay, it's today is the first lecture. I'm not solving so much problem. I'm just giving you some very easy concepts and some very factual things. Okay, because we are just starting our syllabus, so it's I think it's a first class. Okay, now so this is all about the formula of force, and the unit is again Newton. We consider it the unit is same as Newton. Okay, now this is the scalar form. Okay, this is the magnitude form of this is the magnitude form. This is not a vector form. This is the magnitude form of Coulomb's law. Okay, now let's talk about the vector form. Means if you consider a vector, because electrostatic force is a vector force, and how to define direction? How to define direction? How to define direction? So to define a direction, or you can write here vector form. Vector form. Okay. So if I consider a charge q1, if I consider a charge q1, okay, so in your numerical you will use that formula, means F is equals to 1/4 q1 q2 by r square. But to know what is the direction, we have to we have to use the vector form to know the exact direction. Okay, but most of the question will based on the previous formula, which is only magnitude form. Okay, most of the question will ask on that formula, which is magnitude based, and this formula is for, this concept is for to discuss what is the direction of force when we are considering two or more than two charges. So if I consider a charge q1, I'm writing here so that I can add a line between from center to center, q1, and this is a charge q2, and if I draw a line from its center to its center, okay, so in this case, the q1 charge try to apply a charge on q2 if these two charges q1 q2 are similar charges. Okay, if these q1 q2 are similar, both are similar charges, I consider here both the charges positive one. Okay, so if both the charges are positive, then what happens, they will try to repel each other. Okay, this is an important thing, one important thing, that similar charges repel each other and dissimilar charges attract each other. Means one positive, another positive will repel each other, and one negative repel each other, and one positive and one negative attract each other. Okay, so here q1 and q2 will apply a force, both are positive, so q1 and q2 will apply a force. Q1 will try to push q2 in this direction, okay, in this direction, and q2 will try to repel this q1 in this direction, okay, and here the distance between q1 and q2 is r. Okay, so the first one is like the force on the force on q2 due to q1 is, tell me what is the force. The vector form is, this force is 1/4 pi epsilon naught q1 q2 by r square, and the direction is the direction of force, the force on q2 due to q1. What is the direction? Direction is in right hand side, means positive, so I'm defining it as r cap. Is it clear? Where r cap is a unit vector, where r cap is a unit vector. Is it clear now? Because the q1 is trying to repel q2 in right hand side direction, so in right hand side direction, the unit vector corresponding is r cap, positive r cap. Okay, and another, the force on q1 due to q2, the force on, yeah, I should write on here the force on Q2. The force on Q1 due to Q2 is vector F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R square. It is in left hand side, so I can write here minus R cap. Okay, where R cap is unit vector again. Unit vector. So in this way we can define a direction, or we can vector form. We can define a vector form. Okay, so if first charge is throwing Q2 in right hand direction, then we, for right hand direction, we consider it a positive, and if the direction of force is left hand direction, left hand side, then we consider it as a negative. Okay, is it clear? Hello?
Yes, sir.
Okay, so what we learned after charge, we learned the Coulomb force. Coulomb force is very much similar to gravitational force, but remember it's not equal to gravitational force, because Coulomb electric forces are stronger, even 10 raised to the power 32 times is stronger than gravitational force. Okay, okay, so this point actually you can write here. This point you can write here. The electrostatic forces are much stronger than gravitational forces. Okay, gravitational forces. Okay, this is a property of this Coulombian forces. These are very much stronger than your gravitational forces. And the ratio depends on if you are taking one electron and another electron, or it's almost up to 10 raised to the power 40 times powerful then. Okay, almost. It depends also on what kind of charges you are taking. I will do a calculation for these two charges. Okay, so here we discussed Coulomb's law of electric forces, in which I show you the exact formula, which is F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square, and there is a vector form which is F is equals to Q1 Q2 by R square, and here I show the vector form means if one force is applying another with the direction. Okay, so now this is all about Coulomb forces. Now let's try to do a small numerical over this concept. Means suppose I put question, let's try to do a numerical. Suppose I do a 5 microcoulomb charge here. Okay, and another 5 microcoulomb charge here. Okay, both are positive, charge A, charge B. Then question is find charge on P due to A if they are separated by distance 10 raised to the power minus 3 meter. Now try to solve it. Now try to solve this question. The question is clear to all of you? The question is clear to all of you? Are you listening? Me, Mohammed Shafullah?
Yes, sir.
Is it clear? Question is clear?
Yes.
Are you solving it?
Yes, sir.
Okay. And you, Minashi?
Yes, sir.
Okay. Here charge is given, and I already told you what is the value of 1 upon 4 pi epsilon naught. It's 9 into 10 raised to the power 9. And you know the charges, and you have to find what is the value of charge, what is the value of force on B due to A. Find charge, no, find force. I'm really sorry. Find force on B due to A. Okay. You have to find force on B due to A, which is 1 over 4 pi epsilon naught Q1 Q2 by R square, and the separated distance, this is the magnitude. And if I talk about the direction, what will be the direction is from A to B. So direction of force is in this direction. So that is your positive r cap. Okay, if I talk about vector. So 1 upon 4 pi epsilon naught, the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. And put the value and try to solve it and give me the answer. I already give you the hint. I think, do you have any kind of problem? Are you facing any trouble or any problem in solving this question? So do you have any idea what is the value of microcoulomb in coulomb? If you have any question, then you can ask if you are facing problem in solving this question. Are you getting my point, Mohammed Saifullah?
Yes.
Are you solving it?
Sir, can you say how much is 1 coulomb to microcoulomb?
Exactly. So that's the point. This is important point. 1 microcoulomb is 10 raised to the power minus 6 coulomb. So if you put the value is 5 into 10 raised to the power minus 6 and into 5 into 10 raised to the power minus 6 coulomb. Okay, divided by r square means 10 raised to the power minus 3 the whole square into r cap is the direction. So this calculation will give you the answer with the direction. Answer with direction. Okay. So the answer is like 9 into 10 raised to the power 9 into 25 into 10 raised to the power minus 12 divided by 10 raised to the power minus 6 into r cap, and 9, and this is your 9 into 25. Okay, and the powers, try to solve. Power is 10 raised to the power minus 3 into 10 raised to the power plus 6 into r cap, and this will give you 9 into 25 into 10 raised to the power 3 r cap. Okay, So this is your answer. Okay, and this will give you 5, 4, 225 into 10 raised to the power 3 arc. 10 raised to the power 3 Newton arc. Newton arc. Okay, Newton. If I talk about magnitude. Okay, so this is your answer. So this is all about today's lecture. Today I have discussed what is charge. Briefly I discussed what is charge, and after that I discuss Coulomb force, and we do one numerical, okay, on this Coulomb force. I think this enough for today. In our next class, I will do some very good problems on this Coulomb force. I will do some very good problems on this Coulomb force, and I also discussed a comparison between gravitational and Coulomb force, a comparison between gravitation and Coulomb force. And the next thing which I will discuss in my next class is the electric field. Okay, I am repeating again. I will discuss problem based on Coulomb force, and I will discuss electric field. What is electric field? Okay, any question from today's lecture? Mohammed Saifullah and
No, sir.
okay, and Minashi.
No, sir.
Okay, then we can close our today's session. If you don't have any question, then we can close our today's session. Okay. 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 Okay.
Thank you, sir.
Okay. Thank you.
Thank you, sir.